Hi, and welcome to this kind of unexpected part 2 of this first look at Azure AI Foundry agents in C#. Well, if you saw the first video, I talked a lot about semantic kernel not really working, and they might need to fix some stuff. Today there was something called semantic kernel office hours. They are every Wednesday, and I asked them about these specific problems, and they actually gave me some samples on how to actually get it working. And when you see those changes, then you probably will understand why I didn't find it in the first place. But here we are in the code again, and we are running the semantic kernel part. The other part I don't really care about anymore. That's too much code, but we're working with the basic stuff here, which worked before, where we just call the agent, say hello, and it answers back, hello, how can I help you? So nothing new there. That still works. But then we had the code tool that gave some odd code back, which is apparently on purpose. And I will explain what's going on by going in here. But what we saw was that if we look at the message content, we saw just some code here. But that's normal, apparently. First of all, what we can find out is that in item.messages.items, there is stuff in here, and I saw that version here, but there wasn't really anything other than the text itself here again. Well, that is because it is a generic object that needs to be cast to something called an annotation content. And there's various different contents you can hit: file content, image content, and so on. But this is an annotation content, and if we convert it to that when we hit one of those, because the first line here was just the random code. And inside the message, there's some metadata, which I thought it said code lead equals true, but that just means this is a message that you shouldn't show to the user. This is us giving you back the code, which I don't really need for anything. So this is code, and then I don't want to write it out to the user. More about this line in a second. And once we are there, we will get the next message, which is the message back that we wanted, but we still didn't have the file. And that's where the items comes in, where we get items here, and we will see that we have an annotation content here. And the annotation content, once we get to the second part here, will actually hold things about the file ID, which is actually not the file ID, it should be the reference ID, because the file ID is obsoleted. So we can get the file by using the annotation content on the reference ID, where we then get to know that the file is here, and a bit about it, among other things, what it was called when it was inside the Python. Then we can get the file content itself, which we just get back as binary data. And in my case, I'm just saving it to my temp folder, write all the bytes, and run it. So we actually see the image that it produced. And I need to put that in a factory so it doesn't block anything. And then we get to a message now, which is not code, which we then write out. And that message, if we look at it, have this inside it. And you can see it says sandbox and then the file name, which is what the original name was. Now, this is a console app, so we can't really make an MD file, but what we should do instead of saving it and just launching it would be, of course, to put it somewhere online and then replace sandbox : with the original file name with whatever file name we could download it from. And doing all that, we will end up with something like this. In my case, a little odd MD file, but still. Yeah, that was not expected, but that is why we didn't get it in the first place. But this code will be in the sample library repo, so you can get it as well. But yeah, didn't catch this one. Even more odd was the Bing search part, because there is actually a bug here. And the bug in this is that if you already have an agent, like I had, and you, let me move it over here, and you then added to that agent your knowledge of Bing search, then it doesn't work. It simply cannot work with this, and just gave a null reference section. Well, the semantic kernel team don't just use an existing agent, they create a new agent with the tool attached to it. And that works. So in order for me to have it work here, and then we can also see how we can actually create an agent, we need to make a Bing search configuration. And I have incorrectly called it a Bing API key here, because the real key to get this is this long string, which is subscription, my resource group, what resource group it's in, the name of the Azure AI project, and then connections, and then what I have called the knowledge tool. So if we go in here and look at knowledge, and when that's this name. Yeah, I didn't catch that, and apparently it doesn't work again if you already have an existing agent. So we built a new agent instead, and here we can see how we do that. We just give it a name, a model, configuration, and the tool with the Bing tool. And if we actually go in here now and see how messed up it is, we actually get that agent, but it doesn't see it as a knowledge here, but it still has the tool here. So something is definitely odd there, and that is probably up to Azure AI Foundry to fix that. But if we make one, just have the tool, no matter if we can see it over here or not, it will actually work. So if we have our special agent with Bing, and we go in and ask what is the weather in Paris right now, using the Bing tool, we don't get our exception, but instead get back that the current weather in Paris features clear condition around 22 degrees, winds light, and so on and so forth. So then we go in and then we actually delete the agent, so I don't have multiple agents here, just for cleaning up. So yeah, not seen this coming, and I'm kind of worried that all this extra is needed. We can of course build some code around this, but if there's then files and other kinds of tools that we reference, there could be a lot of extra code we need to write inside the normal simply invoke async part. But yeah, it can be done. Kind of funky code. Hopefully they can streamline it a bit at some point, but this is apparently what is needed. So that's the reason for the part 2 video. I hope you find this at least beneficial to now know that semantic kernel is definitely a good choice to use with this system. But again, kind of rough around the edges. Let's hope it becomes better. See you in the next one.